I am Frederick Musa, a student in Engineering Materials MEMT 201 in Section 1. Today I'll be talking to you about the classification of engineering materials. Historical perspective. Materials are deep-seated in our culture. They influence every aspect of industry, from transportation industry to food production industry. Stone Age, Bronze Age, Iron Age were all eras in human history that were classified by the levels of material development. Stone, wood, clay, they're all examples of materials that occur naturally. Classification of materials. Solid materials have been conveniently classified into metals, ceramics, polymers, composites, and advanced materials. Metals. At the top right corner of your screen, you can see an image of that has copper, lead, tin, nickel, steel, and zinc. Metals are usually composed of one or more metallic elements, iron, copper, nickel, and all of that stuff. Atoms in metals are arranged in a very orderly manner. Metals are resistant to fracture, they're relatively stiff, and they have high tensile strength. Metals are ductile, and they're good conductors of heat and electricity. Ceramics. Top right corner is an image of different ceramics: earthenware, stoneware, and porcelain. Ceramics are compounds between metallic and non-metallic elements. Traditional ceramics include those composed of clay, minerals, as well as cement and glass. Ceramics are relatively stiff and strong. They are brittle rather than ductile, they are susceptible to fracture, and they're good conductors of heat and electricity. Polymers. Top right corner is an image of a polymer chain that is made up of a network of monomers. Polymers have large molecular structures that have a backbone of carbon atoms. Polymers have low densities, they're extremely ductile and pliable, they're poor conductors of heat and electricity, they have a tendency to soften or decompose at modest temperatures. Some common and familiar polymers are polyethylene, nylon, polyvinyl chloride, polycarbonate, polystyrene, and silicon rubber. Also, polymers have low densities. Composites. A composite is a compound of two or more individual materials that come from metals, ceramics, and polymers. When you design a composite, you want to attain a single material that has the best characteristics of each of the constituent materials. Fiberglass, very familiar composite. Carbon fiber reinforced polymer, a technologically very important polymer. CFRP are stiff, they're strong, and they're very expensive. Advanced materials refer to materials frequently used in high-tech applications. They include semiconductors, biomaterials, smart materials, and nanomaterials. Semiconductors. Their electrical properties are intermediate of those of electrical conductors and insulators. They're extremely sensitive to impurities, and semiconductors have fully revolutionized the electronics and computer industries through the advent of integrated circuitry. Biomaterials employed in components implanted into the human body to replace diseased or damaged body parts. Bottom of your screen is an example of a very good biomaterial. For something to be a biomaterial, it must not react adversely with any body tissue. Smart materials. Smart here implies that these materials are able to sense changes in the environment, and then respond to these changes in a predetermined manner. Typically, smart material systems include actuators and sensors. Very good example of materials used to make actuators include chip memory alloys, piezoelectric ceramics, and magnetostrictive materials. Nanomaterials, new material class that has fascinating properties and tremendous technological promise. The prefix nanomaterial, nano means 10 to the negative 9 of a meter. And as a rule of thumb, the dimensions of a nanomaterial are on the order of less than 100 nanometers. At the nanoscale, matter experiences very diverse changes in physical and chemical characteristics. In conclusion, materials serve as the raw materials in every facet of human endeavor, and as technology continues to experience rapid growth for the better, more and more classification of engineering materials will be made. Currently, we have metals, ceramics, polymers, composites, and advanced materials as the broad classification of engineering materials.